Okay, welcome back. Today we're going to talk about another type of equation, which is equations that use the distributive property in order to solve. Okay, so just beginning here, we can see that this equation is going to use the distributive property because you have a number that's outside of parentheses. So the first thing you want to do when you have equations that need to be simplified on either side is you want to simplify them. Right here, I want to simplify the left-hand side here. I don't want to start working my way by subtracting 1 from both sides. I just want to simplify the left-hand side and the right-hand side if it needs to be before I start to use inverse operations. So essentially, you want to treat each side of the equation like expressions, and you want to simplify them as far as you can until there's no simplification on either side, and then you use inverse operations to isolate the variable and solve the equation. So here, just this expression on the left-hand side here has distribution that I need to perform in order to simplify it, so I'm going to go ahead and do that. So I have 3x minus 15. Remember, the number outside means that you are multiplying to both of the terms here, not just the first term. And I have this plus 1 outside. I'm going to carry down the right-hand side of the equation, but I'm really just ignoring the right-hand side right now. Here I can combine these two terms. So if we're subtracting 15 and adding 1, really we've only subtracted 14. Okay. So now the left-hand side is a simplified expression. I can't combine 3x and 14 because one is a term with an x in it and one is a constant. So the left-hand side is a simplified expression, the right-hand side is a simplified expression. Now I'm going to start using inverse operations to isolate the variable. And again, this is a type of equation where we have the equations with variables on both sides. So I'm going to remember that lesson, which is subtracting the smaller amount of the variable from both sides. So this is just like 1x, right? When we don't see a coefficient of x, it's always 1. So we have 2x minus 14 is equal to 2, and then we're going to add 14 to both sides. So we have 2x is 16, and divide each side by 2, we have x is equal to 8. Okay, in the interest of time, I'm not going to go back and check it, but you can definitely, actually I can just sort of run this through really quickly. 8 minus 5 is 3, 3 times 3 is 9 plus 10, and that's the same thing as 2 plus 8, which is 10. Okay, so I can just visually check it and make sure that it's the same. Okay, so again, let's just look at the equation for a minute. The left-hand side is a simplified expression. The right-hand side is not a simplified expression. There's things that I need to do in order to simplify it. So I'm going to go ahead and do that and pretend like the left-hand side. I'm going to bring the left-hand side of the equation down, but I'm going to pretend like it's not there. I'm not going to use inverse operations and work between the sides yet. So here, I'm distributing a negative number, so you have to be very careful here. This is negative 4 times k, which is negative 4k, and this is negative 4 times 1, which is negative 4. So I'm going to carry that through by making a subtract 4 here. So I'm translating the sign of 4 into a subtraction of 4, into the operation of 4. Okay? Okay. Now this situation right here, again, the right-hand side can be simplified a little bit further, so I'm going to go ahead and do that before I use inverse operations. If I'm subtracting 4 and I'm subtracting 3, then really what I'm doing is I'm subtracting 7. Okay, and if you can't see that right now, what you can do is you can do a chain of keep, change, change. Keep, change, 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 which is keep this one, change this one to addition, change this one to an opposite, change this one to addition, change this one to its opposite. Negative 4 plus negative 3 gets you that negative 7 or the minus 7. All right? So if you still need to use keep, change, change, then by all means go ahead and do that. Whatever you need to do to get that answer right. Okay? So here I have the left-hand side and the right-hand side are both simplified expressions. Now I'm going to go about changing, working with inverse operations and moving them from the side. Only when they're simplified expressions should I do that. Okay, I cannot tell you how many times students start to try to work with equations when they're not simplified expressions on both sides, and they get totally confused about what to do. So make sure that you've simplified each side first before you start moving things from one side to the other. Okay, here I'm going to add 7k to both sides because that in the end gets me that positive 3k. So we have 5 is equal to, here this is positive 3k minus 7. And I'm going to add 7 to both sides here. So I have 3k is equal to 12, and I'm dividing by 3 here. And I have k is equal to 4, okay? And this is the same thing of saying k is equal to 4 right here. 4 is equal to k is the same as k is equal to 4. And you don't actually have to switch them around. This property right here is called the symmetric property, meaning expressions can be switched around the equal sign and it would be totally fine. Like up here, I could have switched these around, these expressions right here around the equal sign if I wanted to, if that were advantageous for me to do that because of the symmetric property of equality. So I could put this back in here and check it if I wanted to. We'd have 5 minus 28 should be the same thing as negative 20 minus 3, right? 5 minus 28 is, what is that, negative 23, and that's the same as, this is also negative 23 on this side. So I just checked it visually. Okay, here's another one that has a fraction that I need to distribute through. Not a big deal. We know how to multiply fractions. 3/4 times x is just 3/4 x. Minus, okay, so we have 3/4 times 13, and I'll put 13 over 1. That's going to be 39/4. Okay? And that's going to be equal to, okay, so this equation has two sides that use the distributive property. Should be negative 18 plus negative 2x. Okay. Now I'm in a situation where I have fractions and I have variables on both sides. So it's like a combination of the previous two lessons. I'm just going to go ahead and start solving it with the fractions here. I'm not going to try to get rid of the fractions because I'm not that worried about them. Here, let me go ahead and add 2x to both sides. Again, I'm adding 2x because that gets you a 0 over here, which is ultimately what you want. Okay. And you know what, instead of writing 2, what I should write, because I know eventually I'm going to have to get a 4 in the denominator, 2 is the same as, what is it, 8 over 4, right? So I'm going to strategically write this as 8 over 4 because I know I'm going to have to add these two together. And since these are the same thing, I'm just going to write it like this. Okay, so now I have these coefficients. They're ready to add together. I add the numerators to get 11 over 4x minus 39/4. And that's equal to negative 18. Okay. And here I'm going to add this 39/4 over here. Okay. And so I have 11/4 x is equal to, now I need to get, this is negative 18 over 1, so I need to get them so that they are common denominators so that I can add them together. Now, what I want to do is, let's see, what's 18 times, because I have to multiply it by 4 over 4. So 18 times 4 is 232/72. So I have negative 72 over 4 plus 39/4. Okay. Well, negative 72 plus 39, that's going to be the same thing as 72 minus 39. So there's 12. This would get me 6. So that's 3 and 3, so it would be negative 33. So let's write this. 11/4 x is equal to negative 33/4. Okay? And actually what I could do if I wanted to, since they both have 4, let me just go ahead and multiply each side by 4, and that cancels the denominators on both sides. I'm allowed to do that because I've done the same thing on both sides. Okay? And let's divide each side by 11, and I get x is equal to negative 3. This may not have been the way that you chose to solve it. There's a lot of decisions that I made as I was going down through here. You know, I made decisions about not getting rid of the fractions to begin with. You may have wanted to get rid of the fractions, so you could have multiplied everything by 4 to begin with, and that would have gotten the 4 away from here, and this would just become negative 8. You could do that to begin with. It would have made it a little easier. You could make a decision here to turn it into a proportion if you wanted to. There's lots of decisions that you have to make, and as long as you're doing everything correctly, then you should arrive at the same answer at the very end. Okay? Okay, now we have a word problem that deals with the distributive property. Okay, so this word problem says the Coleman family had their bill at a restaurant reduced by $7.50 because of a special discount. Okay, so they had, if X is the bill amount, then what they paid was X minus $7.50, right? Because they had it reduced by $7.50. They left a tip of $8.90, which was 20% of the reduced amount. How much was their bill before the discount? Okay, well, $8.90 is, so there's an equation here. $8.90 is 20% of their original bill. So it's 0.20% of their, not the original bill, the reduced bill, which we said was X minus $7.50. Okay, so let's just go through this. 20% of what they paid was $8.90. Okay, so now we're going to have to, let's go ahead and solve this. Let me make this a little bit smaller here. Okay, well, this uses the distributive property, but it's also an instance where you have an equation with fraction coefficients or decimal coefficients. And what I like to do is I like to make these into fractions so it's a little easier for me to solve it. Because when I don't have a calculator, it's easier for me to think of this as, well, 0.2 is 2/10, but it's also 1/5. So let me make this into 1/5. This way I can easily do it without a calculator. So it's 1/5 times X minus 750. And you know what, let me go ahead and make this into 15/2. 750 is 15/2. It makes it a little easier to multiply. Again, these might not be the decisions that you make when you're solving these problems, but I like to do it this way because, so here I multiplied 1/5 by 15/2 to get 15/10. I like to do it this way because it's a little easier for me to solve it this way. Okay, here I want to add 15/10 to both sides. Well, 15/10, I can actually turn this back into a decimal so that when I add it on this side, it's a little easier. 15/10 is 15 divided by 10, which is 1.5 or 150. So let me go ahead and strategically write that here as 150. Notice I'm fluently operating between fractions and decimals so that it's a little easier for me to, again, to do this, find the answer to this problem without using a calculator. Okay, when I add it over here, it gets rid of it, so I have 1/5 X is equal to, let me see here, carry the 1 here, this would be $10.40. Well, 1/5, let me just turn that back into 2/10, right? So we have, actually it might be a little easier if I want to do 1/5. Actually, it's a little easier to do it this way. Since this is just 1/5, all I have to do to get rid of it is multiply each side by 5. And that gets rid of it here. And $10.40 times 5 is pretty easy to do out this way. This is 20, so this is 22, carry the 2. This is 0, which is 2 when I add it, and that's 5. So 52.50. So X here is equal to $52.20. Okay, so the original amount was $52.20. I took away $7.50, and that's the end of the lesson for today.